So let's jump right into a really fascinating scientific idea. What if you could ask the most basic building blocks of matter a simple question? Hey, do you naturally like to create patterns? Well, that's pretty much what this proposed experiment sets out to do. And just so we're clear right from the start, this is not about creating life. It's about exploring something way, way more fundamental.
Okay, I know what a lot of you are probably thinking when you hear about experiments mixing up the basic ingredients for life. It's a loaded question for sure, and honestly, it's the single biggest misconception about this kind of research. So let's just tackle it head on, right now.
So the short answer, absolutely not. A hard no. This experiment has zero to do with creating life. And the scientists behind the proposal, well, they couldn't be more clear about this.
In fact, probably the most crucial thing to get is what this experiment isn't. The goal here is pure exploration. It's really just about observing how basic chemicals behave when you put them under certain conditions. It's not about trying to spark some kind of biological event.
And this quote from the paper itself really says it all. They call it a feasibility probe. You know, it's kind of like before you try to bake a ridiculously complicated cake, you first checked if your flour and water can even make a simple dough. That's all this is. It's asking a tiny question, not trying to prove some giant truth. Okay, so if we're not making life, then what is the big idea? Well, it all comes down to a concept called assembly heuristics. I know, it sounds super technical, but stick with me. It's actually a pretty simple and honestly a really powerful idea about how patterns get made at the most basic level. So here's the deal. What if you take a bunch of simple components and you put them under some kind of constraint? Add some heat, some light, stick them on a specific surface. What if they don't just jumble up randomly? This theory says they might actually start to self-organize into the same simple patterns again and again.
The Lego analogy is perfect for this, right? You shake a box of loose Legos, and all you get is a random mess. But what if the inside of the box isn't smooth? What if it has little bumps and grooves? Those are your boundary conditions. Now you shake it, and suddenly, you might start seeing the same little shapes, like 2x2 blocks, forming on their own. The constraints are nudging them into order.
And that, right there, is the core question of this whole experiment. Just forget biology completely for a second. The question is this. If we take the stuff that was around before life ever existed, and we just give it a little push with things like heat and light, do these molecules start building things all by themselves?
All right, so what exactly is in this soup they're talking about? Well, it's made up of only what they call prebiotically plausible molecules. In plain English, that just means stuff that we're pretty darn sure was already hanging around on the early Earth long before life ever showed up.
And this is the really cool part. Every single one of these ingredients can be made without life. I mean, we've literally found amino acids on meteorites that have fallen to Earth. We've seen lipids form near deep-sea hydrothermal vents. The building blocks for sugars, they're floating around in interstellar space. So the key thing here is there's no cheating. They're not using any ingredients that were already made by living things.
Okay, so you've got your prebiotic soup. Now where do you put it? This is where it gets really clever. They're not using a beaker. They're using this tiny little microfluidic chip that's basically a miniature landscape of different environments, all in one place. So think of this chip less like a test tube and more like a whole planet in miniature. It's got over 20 parallel channels, and each one can be a different world. You can have hot spots and cool spots. You can blast one channel with UV light, kind of like the early sun. You can coat another with minerals, or create a wet-dry cycle like an ancient shoreline. It's an amazing way to test all those different boundary conditions at the same time.
And the actual procedure? It's surprisingly straightforward. Step 1, make the soup. Step 2, inject it into the chip. Step 3, turn on the heat, the light, all that stuff, and then you just watch. Really, that's the core of it. You use really powerful microscopes and spectrometers to just observe. What's forming? Is anything happening? And is it different from one channel to the next?
And this is so important to get. What does success even look like here? It is not creating some little life form. Success is just seeing a pattern. That's it. If the channel that's hot and has a mineral coating starts forming more simple, repeating shapes than the boring, plain channel next to it, that's a win. That's the whole goal.
So, it all boils down to this one simple comparison. You have your control channels, the boring ones with no changes in heat or anything. They show you what the soup does all by itself. Then you have your experiment channels, the ones with all the interesting stuff going on, and you just compare them. If you start seeing more patterns, more organized structures in the interesting channels, well, then you have a pretty good clue that the constraints are what's making it happen.
Okay, so let's say it works. What have we actually learned? For starters, we'd have a real hint that these basic molecules can self-organize, no life required. We'd see that physical constraints aren't just messing things up randomly, they might actually be the very thing that creates order. And big picture, it would be the first piece of real experimental evidence for this whole assembly heuristics idea. It's about finding a hidden tendency in matter itself.
Now, just as important is what this experiment cannot show. It won't tell us how life started. It won't even prove that this specific way is how it could have happened. It doesn't prove the theory is correct in some grand sense, and it has absolutely nothing, zero, to say about any big philosophical or religious questions. The scope here is incredibly narrow, and that's by design.
So, where does that leave us? Well, it leaves us with a pretty mind-blowing thought. On the surface, yeah, this is just about some chemicals on a tiny chip. But if it works, if we find even a glimmer of evidence that matter has this built-in tendency to create patterns when you put it under pressure, then it opens up a huge question. What else in the universe is just sitting there, waiting for the right conditions to snap into a pattern we've never even imagined?